Okay. Transformations of quadratic functions. Our objective for this lesson is to describe transformations of quadratic functions and be able to write transformations of quadratic functions. At the beginning of the year, we were transforming linear functions, our absolute values and our lines. We did some basic intro to transforming quadratic functions. This section we dig into it a little deeper using our transformation rules, okay? Again, there are still 3 different types of transformations, okay? We have our translations. Our translations, or a lot of times that's referred to as slides. Back in elementary, we referred to them as slides. Okay, down here we have our reflections. Back in elementary school, those were referred to as flips. And then we have our stretches and our shrinks. Okay, there's no shorter word for stretch or shrink. Okay, so first of all, let's go over our translation rules. If I have a function, let's say I have a function f of x, and I want to translate that vertically. Again, remember vertically is that up or down. So to translate this function up or down to obtain a new function, we are going to add on the outside of that function to translate it up. So that will move it up. And we will subtract on the outside of that function to translate or move this function down. Okay. Again, that's something we already know. We've been working with that type of transformation. Okay, a horizontal translation, left or right, again is adding or subtracting inside the function. But again, we have to remember that horizontal works backwards. You add to go left, you subtract to go right. So, f of x minus c, so again, this is different. This is I'm taking the function and adding c onto the end. Here I'm taking x minus c and putting it into the function. This is going to translate my function to the right, c unit. So that's going to move it to the right. Okay. Now, if I have f of x plus c, if I add inside that function, it's going to move it to the left, c units. Because again, horizontals work backwards. Negative actually goes to the right, positive actually goes to the left. Okay, so let's go ahead and let's describe the transformation of f of x equals x squared. So again, this is my parent function. Again, this is my parent, my quadratic parent function, represented by, here's my new function, g of x, and we want to figure what do we do to this parent to get to this child. So first of all, let's break it down into pieces. There's 2 different things going on inside this function. So again, this is our new function, g of x equals x plus 4 to the second minus 1. The first thing I noticed is this minus 1 on the end. Oh, let's pick a different color. This minus 1 on the end. Okay, subtracting 1 on the end looks like this one right here. I'm taking my function and subtracting 1 on the end. So that's going to shift it down. So that minus 1 is going to translate this down 1 unit. So it's going to translate it down 1 unit. Okay, but then we have this x and we're adding 4. Now we need to ask ourselves, where am I adding 4? This adding 4 is inside of the squared function. So it's inside of my x squared. It's x plus 4 squared. So since this thing is inside, okay, it works like this. I'm taking x plus c inside. Again, these are inside the function. Horizontal translations are inside the function. Vertical translations are outside or on the end. Okay. So since I'm adding 4 inside the function, adding 4, again works backwards, that's going to translate me left. this is going to, that -4 is going to translate left 4 units. Okay, and then it says graph each function. So first let's graph the parent. So I'm going to graph the parent here in pink. So let's graph this parent function. Okay, the parent function for a quadratic, when I put a 0 in that, I get out a 0. A 1 squared is 1. 2 squared is 4. 1, 2, 3, 4. So forth. -1 squared is 1. -2 squared is 1, 2, 3, 4. So it's going to give me this kind of quadratic. So now without even plotting points, I know my child function. Oh, let's label this. Let's label our first one. This is my f of x function. My child function is going to do what? It's going to translate it 1 unit down and 4 units left. 1, 2, 3, 4. So every point is going to be moved 1 unit down and 4, 1, 2, 3, 4 to the left. So like this point, 1 unit down and 4 to the left. 1, 2, 3, 4. This point, 1 unit down and 4 to the left. 1, 2, 3, 4. Right there. This point, 1 unit down and 4 to the left. 1, 2, 3, 4. This point, 1 unit down, 4 to the left. 1, 2, 3, 4. So my new function, my translation looks like that. So there's my g of x, my child. Okay. All right. Now reflections. Reflections are flips. If you want to reflect about the x-axis, so again, the x-axis is this one. So it's going to flip it from one side of the x-axis down or back up, depending. If I want to flip it over the x-axis, I need to put it out in front of my function. So put a negative out front. So this is a negative out front of my function. So it's going to take a negative times my whole entire function for an x-axis reflection. For a y-axis reflection, again, it's going to flip it over, the up and down, the y-axis. I need to put the negative inside on my x. So again, this negative now goes inside on the x. Okay. For a y-axis reflection. Okay. So now our stretches and shrinks. I know a lot of times we get confused on stretches and shrinks. The vertical ones I think are pretty straightforward. You just multiply out front, outside, out front of your function. So for a vertical stretch or shrink, I multiply a constant out front of my function. So I take c times my function f of x. Okay. Okay, and what this c is determines whether it's a stretch or a shrink. Okay. If c is greater than 1, so if c is greater than 1, it'll be a stretch. Okay. But if c is a fraction in between 0 and 1, it'll be a shrink. Okay. It makes it that many times smaller. And again, what a vertical shrink is doing is, if we think vertically, it's pushing my function down or up. So if I have my function, let's just do oh, that's a horrible parabola. Let's draw a little better. What a vertical shrink is doing is let's take all of my points and making them either, if it's a stretch, it's going to pull all my points straight up. It's going to pull all my points that many times straight up for a stretch. So that's a stretch. If it's a shrink, it's going to pull them all down towards the axis. So here's my axis. Okay. It's going to pull them all away that many times. So again, a stretch is a multiply, so it's going to take it that many times up. So if you multiply by 4, it's going to make all my y's, it's going to stretch all my y's 4 times farther away from the axis, okay, or 4 times farther down. Whereas a shrink is going to pull them back down towards the axis. Okay, it shrinks it, squishing it towards the x-axis. So a vertical stretch stretches it away from the x-axis. A vertical shrink shrinks them back closer to the x-axis. Okay. Again, a horizontal stretch or shrink works backwards. Okay. And again, this is now you multiply inside times your x, the c there inside. So again, you multiply inside for a horizontal. But how it works backwards is if c is greater than 0, it's going to be a shrink. Okay. And it's going to be a shrink by 1 over c. So if your c is 8, it's actually going to shrink it to 1/8 its size. Okay. If c is in between 0 and 1, sorry, that should be greater than 1, typo, fix it. If c is greater than 1, it's going to be a shrink by 1 over c. And if c is in between 0 and 1, it's going to be a stretch. Again, still by 1 over c. So if this is a fraction, it's actually stretching it by the reciprocal of that fraction. So we have that reciprocal idea. Okay. So how this one's working is if I have, let's just draw a random parabola, and let's draw a coordinate, is this is actually pulling your points in this way. So it's going to shrink them in. So let's go ahead and let's put my axis in the middle. Hopefully you're writing notes in pencil. Okay, so it's going to shrink. Again, a horizontal shrink is going to pull those points in. A horizontal stretch is going to pull those points out. Okay. All right, next page. Let's do some transformations. Okay, describe the transformation of, again, here's our parent function, f of x equals x squared, represented by g. Then graph each function, okay? So, first of all, we have to ask ourselves, are things inside or outside of our function? Okay, here in this case, my negative is out in front, because here's my x, the negative 1/2 is out in front. First of all, this negative out front. So let's go back and let's look at our translations. A negative out front is going to do what? It's going to reflect it in the x-axis. It's going to flip it from up to down. So we're going to have an x-axis reflection. That negative is going to do an x-axis reflection. Okay, so that's what that negative is doing. That negative sign right there is going to give me my x-axis reflection. Okay, and now this 1/2, again, where is that 1/2? Is it inside on my x, or is it out in front of my x squared? That 1/2 is out front of my x squared. So since it's out front, like here, this c, it's going to be a vertical stretch or shrink. And since it's in between 0 and 1, it's a fraction, it's going to be a vertical shrink. So it's going to be a vertical shrink by 1/2. So that 1/2 out there is going to give me a vertical shrink by a factor of 1/2. Okay. So what that means is vertically, up or down, it's going to shrink all my points and make them half the distance away from that x-axis. So let's go ahead again. Let's draw in our parent function. You're going to get pretty good about sketching in parents. So we'll have 0, 0, 1, 1, 2, 4. Okay. So now let's sketch them in two different parts. First I'm going to sketch the x reflection. So it's going to reflect it down. So it's going to reflect all of these points. Instead of being up here, they're going to be down here, because it's an x-axis reflection, so it's reflecting it down. So I'm going to sketch that. So instead of 2, 4, it's going to be 2, negative 4. Okay. And I'm going to sketch that in just kind of dotted. Okay. So there's our x-axis reflection. Okay. All right, but now I want to shrink it vertically, meaning I want to move all these points half the distance away from this x-axis. I want to shrink them all in. So instead of being, well, 0, 0 is already on the axis. I can't shrink that at all. But instead of being at 1, 1, I need to pull it in halfways. So it's going to have to go here. Instead of being at 2, 4, I have to pull it in by half. So it's going to have to be the point 2, 2. So it's going to do that. Again, it just pulls those in vertically. Okay, so there in purple is my new g of x. That blue is just our halfway point. This pink is my f of x. Okay. All right, let's look at part B here. Okay. All right, so here for part B, first things first, again, I noticed this plus 1 on the end. What's that going to do? So my plus 1 on the end, we should get pretty good at those. That's going to shift this up 1 unit. So we know that plus 1 is going to shift it up 1 unit. So we need to go up 1. Okay. And then now we have this little 2 in here. Okay, let's ask ourselves, is the 2 out in front of the whole function, or is it in? Well, it's inside on that squared, so that's inside. So that's going to be a horizontal stretch or shrink. And again, horizontal works backwards. So since it's a 2, it's going to be a shrink by half. So, and the way we get half is the reciprocal of 2. 2 is the same as 2 over 1, so the reciprocal is 1 over 2. So this is going to be a horizontal shrink by 1/2. So horizontally, left and right, I need to shrink everything in by half. So again, let's draw our parent function. 0, 0, 1, 1, 2, 4. So there's our parent. Okay, there's my parent f of x. Okay, so now again, let's do our in between. First thing, let's shift this thing up 1. So up 1. We'll come right here. So again, it's going to shift all of these points up 1. So now we'll have this function. Again, I'm going to kind of do it dotted because this isn't our final. This is just our shifted up 1. So there's my shifted up 1. Okay. And now for my final one, I want a horizontal shrink by half. I want to take all these points and bring them half the distance in. So, well, let's see, 0, this point right here, I can't come any farther, it's already on that axis. But now this point, I can bring it in. I can pull it in. Again, we want to go half the distance in. So instead of being over 1, up 1, we're going to go over half and up 1. So we're going to be right here. Same with this point here, this blue point. We're going to go half the distance. So instead of being over 2, it's going to be over 1. So again, we're just cutting everything in half as we come in. So there is my new function. So there's my horizontal shrink by 1/2. So there's my g of x. So it's shifting it up 1 and shrinking it horizontally. Okay. All right. Now we have what's called the vertex form of a quadratic function. Again, our quadratic parent is f of x equals x squared. Okay. So we can actually put all of our transformations kind of together for this form. Okay. So all this is doing, again, a is just a number multiplied out front. The minus h in here is just a number added or subtracted inside. And the plus k is just my number added outside. So again here, we still have x is really our variable. The a, the h, and the k are just how it's being translated. Okay, so let's go ahead and let's do the most basic, the one we know for sure. This plus k on the end. That's going to do what? That's going to move it up and down. Remember, the plus k on the end indicates it up and down. So this plus k is our vertical translation up, down. That's our vertical translation. Up, down. Okay. This minus h, I don't know if some of you are wondering, why is it a minus h and this is a plus k? Again, the minus h inside is a horizontal, and horizontals work backwards. So if it's minus h, it goes right. If it's plus h, it goes left. So we denote that it works backwards by putting the negative on it. So this is our horizontal translation. This tells us which way we're horizontally translating, so that's our left and right. And this a out front, again, multiplying out front by a number, is our vertical stretch or shrink. But it also reflects, because if it's positive, it doesn't do anything, but it can also reflect in the x-axis if it's negative. So it's also a reflection in the x-axis. Reflection in x-axis if it's negative. So that A does double duty. If it's a number, it's going to stretch and shrink. If it's negative, it's going to reflect. Okay. All right. So let's go ahead and let's do here example 3 where we're actually going to write our translation. It's very important on multiple translations to do one at a time. Only translate one thing at a time. Okay. So let the graph of G be a vertical stretch by a factor of 2 and a reflection in the x-axis, followed by a translation 3 units down of the graph of f of x. So again, this is our parent. So we're starting with f of x equals x squared. At the end here, we're going to get a new g of x function. So we're going to get a new g of x function. Okay, but what we're going to do is we're going to do it in steps. We're going to do one thing at a time. So the first thing I want to do is a vertical stretch by a factor of 2. Okay, so let's look back and let's see what's a vertical stretch do. A vertical stretch multiplies out in front of the function by that number. So basically I want to take my f of x, so for my new, so let's do one thing at a time. Vertical stretch. The vertical stretch by 2. What's it going to do? It's going to take my f of x and multiply out front by 2. So it's going to be 2 times my f of x. So my f of x is x squared. So I want to take 2 times x squared. So there's multiplying it by 2. So there's my vertical stretch by a factor of 2. Okay, next step. Now we want to do a reflection in the x-axis. So what's a reflection in the x-axis do? So now we're going to take this function and we're going to change it again. We're going to do a reflection in the x-axis. Okay, so now we want a reflection in the x-axis. So let's go back. A reflection in the x-axis puts a negative out in front. So now I want to put a negative in front of my f of x. But again, we're translating this is my new f of x now. So we want to put a negative out in front of that. So that's going to be a negative times 2x to the second. So there's my reflection in the x-axis. So there's my new function we're working with now. So now I want to take that, and what do I want to do with it? Last, I want to followed by a translation 3 units down. So now I want to translate it 3 units down. So I'm now going to take this function and translate down 3. So again, to translate down 3, I take f of x and subtract 3 on, subtract 3 on the end. So I want to take my new function, which is negative 2x to the second, and subtract 3 on the end. So did I do a vertical stretch by 2? Yeah, it gave me that. And then I had a reflection in the x-axis. Yep, it gave me that. And then translated 3 units down. Yep, it gave me that. So that is my new g. So my new g is negative 2x squared minus 3. Okay. Then it says identify the vertex. Oh goodness. What the heck does that mean? Okay. What I want you to do is I want you to look on page 50 in your book. So look on page 50 in your book. Okay. And look at, and I want you to read I want you to read the section that says writing transformations of quadratic functions. Okay. Writing transformations of quadratic functions. Okay, it's just a little paragraph right there at the top part of the page. I want you to read that, and from that, see if you can't figure out what the vertex of this one would be. Okay, see if you can't identify the vertex, and we'll pick this example 3 up in class. Okay. All right, so we'll work through example 4 and example 5 at the beginning of class. Example 4 and example 5 at the beginning of class. Okay, but I want you to try your turn 1 and your turn 2 and 3. Okay, so do your turn 1, 2, and 3. We're going to save your turn 4 for in class. Okay, so come to class with those 3 problems attempted. Your turn problems 1, 2, and 3. Okay, and try to find the vertex for example 3, and that's where we'll start in class tomorrow. Okay. Good luck.